students, welcome to Sunil's tutorial. I am Sunil Mirwani and today we will be doing this chapter called as benzene, aromatic compounds. Let's see this. Let's see the chemical reactions of benzene. Now when you talk about chemical reactions of benzene are classified into two categories: addition reactions and substitution reaction. So chemical reactions of benzene are classified into two categories: addition reaction and substitution reaction. Let's see what are the different types of addition reaction. When you talk about addition reactions of benzene, right, you have addition with hydrogen, you have addition with halogen, and you have addition with ozone. You have three different types of addition reaction with, that's your hydrogenation, second halogenation, and third is with ozone. Right, let's see each one of them. First, let's see the addition reaction with hydrogen. Addition with hydrogen. Right, now how does addition with hydrogen take place? What happens when benzene reacts with hydrogen? Benzene reacts with hydrogen. Right, benzene, you have to draw the benzene ring. So benzene reacts with hydrogen. You have an addition reaction. As the name suggests, addition means two or more reactants should combine to give you a single product. Nickel is used as the catalyst at 473 Kelvin. Right? You would have see what is benzene? CH, 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 CH and CH. This is what is benzene, C6H6. When you have addition reaction, all of this will become H2. You have alternate single and double bonds. I will do that. We have alternate double bonds here. Right? So this is what you are going to get. This is called as cyclohexane. This is benzene. So benzene reacts with hydrogen in the presence of nickel at 473 Kelvin to give you cyclohexane. Right? Right. So that's my addition reaction with hydrogen. Next, let's see addition with halogen. What happens when benzene reacts with chlorine gas? Benzene reacts with chlorine gas. Right? Now, benzene, C6H6, draw the benzene ring. Reacts with chlorine gas. Just a minute. In the previous case, I've used 6 hydrogen to balance the reaction. I need to have 3 H2. Only then the reaction will be balanced. Here again, it reacts with chlorine gas in the presence of sunlight. Same addition reaction. Now, we have, this is my benzene ring. Right? One of the bond will be with hydrogen, one will be with chlorine. Again, you will have one bond with hydrogen, one with chlorine. One bond with hydrogen, one bond with chlorine. Right? you would have one bond with hydrogen, one bond with chlorine, you would have one bond with hydrogen, one bond with chlorine, and you would have a bond with hydrogen and bond with chlorine. This is the compound that would be formed. So the double bond that you have, alternate double bond that you have, is used for combining with chlorine. 6 chlorine atoms are used, therefore this is going to be 3Cl2. This is benzene, reacts with chlorine to give you benzene hexachloride. Benzene ring, 6 chlorine, therefore hexachloride. So you will get benzene hexachloride. So what you get here is benzene hexachloride. Fine, do we get this in here? Suppose if I want to know the IUPAC name for this. Name of benzene hexachloride is, now look at this, chlorine is attached to every carbon atom, so this is going to be 1, 2, 3, 4, 5, 6. Chlorine is attached to all the 6 carbon atom. There are 6 chlorine, therefore hexachloro. We are doing IUPAC name, so inorganic comes before organic. And then you have benzene, so this is going to be cyclohexane. So the IUPAC name of benzene hexachloride is 1, 2, 3, 4, 5, 6 hexachlorochlorohexane. Fine, do we get this in here? Okay, so this, where do you use this? It is a powerful insecticide. It is a powerful insecticide. That's my application of benzene hexachloride. Fine, do we get this in here? Next, let's see another reaction. Let's see addition reaction with ozone. Right? What happens when benzene reacts with ozone? Benzene reacts with ozone. Right? Now, benzene. Let's draw the benzene ring first. Alternate single and double bond, reacts with ozone. Right? Now, observe carefully what will happen. You will have an addition reaction. You have benzene, that is C6H6. Right? So this is my C6H6. You have to have, there's a bond between them. You have alternate double and single bond. Now we know that valency of oxygen is 2. So one of which will combine here. One oxygen will combine here. Ozone. The third oxygen will combine here. Right? So where you have the double bond, instead of double bond, this is what will happen. Then you have single bond. Wherever you have the double bond, you will have oxygens there. So oxygen, you will have oxygen here and you will have oxygen in between them. Right? Single bond, and where you have the double bond, you will have oxygens there. Oxygen, oxygen, and you have oxygen in between them. This is the compound that would be formed. This is called as, you have 3 ozones used. So 3O3. This is benzene. This is called as benzene triozonide. Benzene, 3 ozone molecules are used, therefore tri-ozone molecules, therefore ozonide. Now this particular compound is an unstable compound, right? This would react with water, on decomposition with water, in the presence of zinc. If I react this with, say, water molecule in the presence of zinc as catalyst, right? I would have aldehyde group form, CHO, and I would have hydrogen peroxide form, H2O2, hydrogen peroxide, right? I have 6 molecules, I have taken 2 here, so that means to balance carbon I need to have 3 here, right? So my carbon is balanced. Now once this is done, then I've used 6 hydrogens, I've used 6 oxygen. So 6 carbon, 6 hydrogen, 6 oxygens have been used. Now I have 9 hydrogens, so I need to put a 3 here and 3 here to balance the reaction, right? So that is going to be my reaction. This is going to be called as glycol. So you will get glycol and hydrogen peroxide. So this is going to be my addition reaction with ozone. Finally, get this in clear. Next, let's move on to substitution reactions, guys. Now, when you have substitution reaction, I said that benzene undergoes addition reaction and substitution reaction. Right? Now, in substitution reaction, it undergoes halogenation, that is, it reacts with halogen. Right? Next, it is also going to undergo nitration. That's the second substitution reaction that you have. Third, you have is sulfonation. And the last you have in substitution is called as Friedel-Crafts reaction. Right? So these are the 4 substitution reactions that benzene undergoes. Let's try to see each one of them in detail. First, let's see halogenation. Right? We are doing halogenation means adding halogen. Right? What happens when benzene reacts with chlorine? Benzene with chlorine, right? Now you will say, sir, you've already done that reaction. You've already done benzene with chlorine, right? Now, how do I know that it is going to be a substitution reaction or is it going to be an addition reaction? The difference is going to be in the catalyst. If you have benzene reacting with chlorine in the presence of sunlight, then it is going to be an addition reaction. If you have benzene, see, I'll show you this. Benzene reacts with chlorine. The catalyst is iron or red phosphorus. These are the 2 catalysts. If you have these catalysts, then what you get is called as, what you will get is not addition reaction, but you will get substitution reaction. Fine, do we get this in here? Now, in this case, you will get benzene substitution reaction. 1 chlorine, 1 hydrogen is substituted, that will react with another chlorine. So what you get is, this is benzene, this is chlorobenzene plus hydrochloric acid. I could show you another reaction like this. What happens when, say, benzene reacts with bromine gas, right? Benzene reacts with bromine gas. Again, you will have benzene reacts with bromine, right? How do I know that it is not addition and it is substitution? Because I'll be using the catalyst iron or red phosphorus. Substitution reaction, 1 hydrogen from the first carbon atom is going to be substituted. So you will have benzene ring with that hydrogen atom substituted by bromine. The free hydrogen atom will react with bromine to give you HBr, right? So this is going to be benzene, this is bromo, benzene. Fine, do we get this in here? Next, what happens when, say, if I heat the reaction, suppose if I have benzene reacts with chlorine at higher temperature. Benzene reacts with chlorine at higher temperature. Right? Let's see this. Benzene reacts with chlorine. I could draw the double bond this way or just put a circle, either way. Reacts with chlorine at higher temperature. Your catalyst would still remain the same. You would use iron or red phosphorus as catalyst and you would heat the reaction, right? Now, if you remember in the previous lecture I had taught you the positions, right? Can we just recap the position before I complete the reaction? We had said that, guys, can you just see this? 1, 2, 3, 4, 5, 6. I had given you that if I have substitution at 2, then that is called as ortho. 2 and 6 is called as ortho. Then we had done that 3 and 5 is called as meta. And 4 is called as para. So if I have substitution reaction taking place at these positions, those would be the names that would be given to them, right? Now, in this case, let's try to see this. What you will get is, you will get two different compounds. You will get chlorine and chlorine, and you would also get chlorine and chlorine and 2HCl, right? So in that case, to balance this, I need 4 chlorines, right? And I will need 2 benzene rings, right? Now let's try to name that compound. This is benzene. You have on the second position, so this is going to be O, 2 chlorine atoms, therefore dichlorobenzene. Ortho is also written as O, right? Next, the next one you have on the fourth position, so this is going to be P dichlorobenzene. So at higher temperature you will get O dichlorobenzene, P dichlorobenzene and hydrochloric acid. Fine, do we get this in here? Let's try to do this at still higher temperature. Suppose if I have benzene reacts with chlorine at high temperature with prolonged heating. If I heat the reaction for a very long time, let's see what would happen. If I have benzene, that's my benzene, reacts with chlorine, my catalyst would still remain the same, iron or red phosphorus. I'm going to heat this for a very long interval of time. You would have total substitution, that means all my hydrogens would be substituted by chlorine. So I'll have benzene, where all your hydrogens are substituted by chlorine, right? And you will have HCl. I need 12 chlorines, so this is 6, and 6 hydrogens that have come out will come here. This compound is benzene, and this is 6 chlorine, so hexachlorobenzene, right? So what I'll get is hexachlorobenzene. So this is my halogenation reaction with benzene, yeah, right? Okay, next let's see this. Next let's see nitration reaction. Now what is nitration? Nitration means reacting with nitric acid, right? Now what would happen when, say, benzene reacts with concentrated nitric acid. Benzene reacts with concentrated nitric acid. What would happen when benzene reacts with concentrated nitric acid? Let's see this. That's my benzene reacts with HNO3. We are saying that concentrated nitric acid. Here you will be using the catalyst concentrated sulfuric acid, and the reaction will take place at 323 Kelvin. Now at this particular reaction, you would have substitution that would take place. You would have the nitro group that would be substituted. One hydrogen will be substituted by the nitro group, right? So that means NO2. That means one O is remaining, one H from here and one H that is substituted. So you will get water, right? So this is benzene, and this is going to give you nitrobenzene. So you will get nitrobenzene and water. Let's see if I conduct this same with 373. If I change the temperature, benzene reacts with concentrated nitric acid at high temperature, right? Let's see this. You have benzene reacts with HNO3. The catalyst is still concentrated sulfuric acid, and the temperature is going to be 373 Kelvin. Instead of 323 Kelvin, I am reacting it at 373 Kelvin. So in that case, what I will get is, at higher temperature, you will have two nitrate groups that would come out. So you would have NO2 plus H2O. Two nitrate groups. That means I need to put a 2 here and there will be two water molecules. So this is benzene. Since the second nitrate group is attached to the third position, this is going to be M, two nitro groups, so dinitrobenzene. Right? So that will be the reaction. Let's see another reaction. What happens when benzene reacts with concentrated nitric acid at high temperature with prolonged heating? No. Right? What happens when benzene reacts with concentrated nitric acid at high temperature with prolonged heating? Right? Let's try to see this reaction, guys. Let's put this out. Benzene. First, let's draw the benzene ring. Benzene reacts with nitric acid, HNO3. My catalyst still remains the same. Here, this is going to be concentrated sulfuric acid. I keep my catalyst same, and you are also going to put in, this is going to be prolonged heating. We will heat this for a very long period of time. So instead of, as I go on increasing the temperature, more and more nitrate groups get substituted. At lower temperature, one nitrate group got substituted. As I increase the temperature, the second nitrate group got substituted. When I further increase and heat for a longer period of time, the third nitrate group will also get substituted. So this is going to be NO2, and you will have NO2 and you will have NO2. I need 3 nitrate groups, therefore this will be 3H2O, 3 water molecules. This is going to be benzene, and this is going to be 1,3,5 trinitrobenzene. First position, third position, fifth position, tri, 3 nitro groups, benzene.
So we would write meta like M.
No, because I have 2 molecules, I'll have to then write dimeta di this. So instead of that, we write it as 135. In that case, we write it in terms of number. Fine, do we get this in clear? Okay, so that was my substitution reaction of nitration. Next, let's see the third substitution reaction. Let's see sulfonation. Right, sulfonation is reacting with sulfuric acid. What happens when benzene reacts with concentrated sulfuric acid? Reacts with concentrated sulfuric acid, right? Benzene reacts with concentrated sulfuric acid. The reaction takes place at 373 Kelvin, right? Concentrated. Obviously, if it's a concentrated acid, the first thing that will happen is dehydration. Water molecule is going to come out, sulfate group is going to get substituted. Guys, if you apply a little logic, water molecule has to come out. One hydrogen will come from benzene. That means one H and one O will come out from here. That means that will give you with one O is out. So that will give me SO3H. Right, so this will be benzene. And this is going to be benzene sulfonic acid. Benzene sulfonic acid. Fine, do we get this in clear? Next, let's see, suppose if I use a catalyst in this reaction. Benzene reacts with concentrated sulfuric acid in presence of sulfur trioxide. Presence of sulfur trioxide. I'm using sulfur trioxide as catalyst. So benzene reacts with concentrated sulfuric acid. The temperature remains the same, 373 Kelvin. I'm using sulfur trioxide as the catalyst. Now, due to the presence of catalyst, instead of one sulfate group coming out, you would have two sulfate groups coming out. So in which case, you will have benzene, SO3H and SO3H. Two sulfate groups means I need two sulfuric acid. Therefore, two water molecules will be formed, right? This is benzene. This is attached to the third position, so this is M. That's your meta position. Benzene disulfonic acid. Right? Okay, next, let's see another reaction. The fourth substitution reaction that you have is called as Friedel-Crafts reaction. It is also referred to as action of alkyl halide. What is Friedel-Crafts reaction? Now guys, benzene is an organic compound, right? If I react an organic compound with another organic compound, that is what is Friedel-Crafts reaction. It is the replacement of hydrogen atom from the benzene ring of an alkyl group. Right? I'll show this to you. For example, I'll show it to you with the help of an example. What happens when benzene reacts with, say, methyl chloride? Benzene reacts with methyl chloride. Benzene reacts with methyl chloride. You have an aliphatic compound reacting with an aromatic compound. Catalyst is anhydrous aluminium chloride. Right? And you're going to heat the reaction. Now, when benzene is treated with methyl chloride, in the presence of anhydrous aluminium chloride, which acts as a catalyst, you would have alkylation taking place. Alkylation, that is hydrogen atom here is going to get substituted by an alkyl group. The hydrogen atom is going to get substituted by an alkyl group. So here hydrogen atom is substituted by the alkyl group. Hydrogen that comes out will react with chlorine to form HCl. Fine, do we get this in here? This is benzene and this is methyl benzene, right? Methyl benzene is also called as toluene. Fine, do we get this in here? So in the case of when you have an aromatic compound reacting with benzene in the presence of aluminium chloride, you have alkylation of benzene taking place, right? To give you an alkyl compound of benzene. Now the same reaction I could do with say ethyl chloride. Suppose if I do the same reaction with ethyl chloride, benzene reacts with ethyl chloride, right? Benzene reacts with ethyl chloride, ethyl, 2 carbon atoms, chloride, Cl, right? Your catalyst would still remain the same, that would be anhydrous aluminium chloride, and you keep the reaction, right? Same substitution, you would have alkylation taking place. So in that case you will get benzene ring as it is, you will get C2H5 plus HCl. This is benzene, this is ethyl chloride, and this is going to be ethyl benzene. Fine, do we get this in here? Okay, where do I use benzene? Why am I studying about benzene? Benzene is used as a solvent in oils and fats. It is also used in the manufacture of dyes, drugs and perfumes. It is used for dry cleaning, and it is also used as a motor fuel under the name benzol. So these are my uses of benzene, right? Okay, we'll stop this here for the day. Thank you very much.